This is WAIS Station running on a Macintosh, one of many platforms where you can run WAIS, the Wide Area Information Server. WAIS lets you search databases around the world, your corporate database, and your own personal information from one simple point-and-click interface. When WAIS Station opens, you see two windows. The Sources window keeps a list of sources or databases that you can search using WAIS Station. We see here a database of connection machine applications descriptions, a directory of servers, which I'll describe in more detail later, encyclopedias, and dozens of other sources which you can search all over the world on the internet. The Questions window keeps track of your stored questions. I'll use the encyclopedia question to look something up in the encyclopedia source. For example, if I want to know about human evolution, I can ask a question in natural English. Who developed theories on human evolution? When I run this question, WAIS Station sends the question using a standard protocol called Z39.50 to the WAIS encyclopedia server, which is running on a connection machine supercomputer. The connection machine compares my question to every article in the entire database and ranks the top scoring documents here and returns them to the WAIS interface, where they're displayed as a headline or a title. I can display one of these documents by double-clicking it, and WAIS retrieves the text of that document. And I see that Leakey greatly advanced the study of human evolution, and he was born in Kenya, and lots of other information. Remember Kenya, we'll get back to that in a moment. Now I can scroll through the list of results here, and I see down here a general article on human evolution. I can open that up and see that indeed this article talks about human evolution in general. And I can improve my search or focus it by dragging the icon for that article up here and telling WAIS Station to find other documents which are similar to this one. I can also go back to my sources window and look up the same question in more than one source at once. For example, I remember seeing some email in Thinking Machines that described something to do with evolution, and I want to know who was talking about that. When I run the question this time, WAIS sends the question and this document to both of these servers, which could be anywhere in the world. Each of them looks up the data, looks up the results in its entire database, comparing the question against the millions of pages of text it has stored in its memory. And both of the results are combined and merged into one results list. The gray bar indicates how closely an article matched the original question. One of these articles here is about a seminar, and if I open that up, I may be able to look up someone's name or find a contact of some expert in the area of evolution. In this case, it was a talk on artificial versus natural evolution. And I could scroll up to the top of the document to get the name of the presenter and so forth. Now, I'm going to use my list of questions to look up something in a different database. We have a saved pictures database, and I've previously run a query to look up maps in the pictures database. And that's one reason you would save a question. I see here a map of Kenya. Remember that researcher was from Kenya. When we retrieve that document, instead of getting text, we'll see that WAIS Station can display graphics as well. Finally, I'll use the directory of servers question to try to find other servers that might have information on human evolution. By asking this question of the directory of servers, I'm looking up descriptions of what's in those databases to see if there are other databases that would be of interest to me. I see a molecular biology source. When I open that up, instead of getting back text or a graphic, I'll get back a source description. A source description comes complete with all the contact information that WAIS Station needs to automatically contact that server for me, all the database information it needs, a description of what's in it for me, and down here a feature that lets me tell WAIS Station to automatically contact that source. For example, every morning at 4 a.m. to alert me to any new information that had been added to that database since I last contacted it that was relevant to the question I was asking. If I saved this source description out, it would appear in my sources window, ready to be used. So, I've shown you how you use the directory of servers to find news sources of information. I've shown you how the questions window keeps track of all of your questions. And I've shown how the sources window lets you keep track of the dozens and now hundreds of servers of data that are available worldwide in the WAIS system. And that's WAIS.
Ultra-fast computers, so powerful, it's revolutionizing work in laboratories and businesses. Many scientists thought such computers couldn't be built for decades, but as David Barron reports, the advanced technology is proving itself today.
This is what many scientists consider the world's fastest computer, unveiled in October by the Thinking Machines Corporation of Cambridge, Massachusetts. And this is the man who designed it, computer scientist Danny Hillis. Until recently, Hillis was considered a fanatic. Many scholars said his ideas for building new, more powerful machines would never work.
There's been a real transition in the industry, which is exciting for us, because we've gone from spending our energy just convincing people we're not crazy to spending our energy trying to build machines fast enough.
Hillis's multi-million-dollar machines, and those built by a handful of competitors, are based on a technology called massive parallelism. Whereas the heart of a traditional computer is a single processor that performs one task at a time, Hillis's connection machine contains dozens to thousands of processors, all working together.
A connection machine inside would look almost like a library shelf, and you'd see a lot of boards which would be lined up like the books in the library shelf. So the boards are the processors, and the wires on the other side is the communications network that talks between them.
By linking those processors in an efficient way, Hillis was able to achieve unprecedented power and speed. In fact, the new connection machine is so powerful, it can do in 1 minute what a typical personal computer would take more than 2 months to accomplish. That power makes the machine valuable to scientists who can use it for designing space stations, simulating the vibrations of molecules, and predicting global climate patterns. At the Massachusetts Institute of Technology, scientists use the ultra-fast machines to create computerized holograms. Making just one of these three-dimensional images can require more than 1 trillion calculations.
People used to spend hours or days computing holograms. We got the connection machine, and right away we were computing holograms in a minute.
Now that massively parallel computers have proven themselves in the lab, businesses are starting to take notice. The American Express Company recently bought 2 connection machines to analyze information on its cardholders. And experts say massively parallel computers are naturally suited to studying the stock market.
The market is lots of independent entities making decisions at the same time, just like a massively parallel machine has lots of independent computers working at the same time.
Thinking Machines Corporation has also exploited its computer's tremendous power by developing a system that searches for information using requests typed in plain English. In a matter of seconds, the computer can retrieve relevant documents from a database containing atlases, encyclopedias, magazines, and newspapers.
And we can get to whole libraries. All of the text, all of the pictures could be on a connection machine, able to be browsed in almost this speed.
But computer developers say the true power of their machines lies in opening entirely new fields for scientific investigation. With the advanced computers, researchers are now simulating the evolution of artificial life forms, creating fantastic worlds that exist only in the mind of a machine.
Until now, most of us have gotten our information from newspapers, television, and other printed media. These are interesting and valuable sources of information, but they have some limitations. The biggest of these is that someone else prepares them for you. Someone else lays out what are the important stories, and that's what you get to see. I'm Franklin Davis of Thinking Machines, and I've been working on the WAIS Project, or Wide Area Information Servers. The WAIS Project was started by Brewster Kahle 2 years ago, and the goal was to create a system that lets people get at all kinds of information in one easy point-and-click interface on their computer. There's lots of different kinds of information that we all use every day. From the files on your hard disk, the documents which you've created, to files that you may share among a work group if you work on a computer together with people, to all the documents in a whole organization, which is really the organization's memory, the reports and memos and proposals and other kinds of documents, which today are stored all over the place, mostly in file cabinets, and are not accessible to everyone. And finally, the world of public information, all the published information that's out there in newspapers, journals, libraries, and so forth. Getting at all of these electronically has been very difficult until now, or even impossible. And the goal of the WAIS project is to bring them all together to one easy interface. The WAIS system is running now on the Internet, which is a global computer network. The Internet contains, at the moment, upwards of 70 servers, each containing different kinds of data that people have made available at their organizations. And these servers are running worldwide, from Norway to Australia and across the US. The WAIS interface is available on various workstations, from the Macintosh to PCs, X terminals, and various other interfaces. And these interfaces and the databases are tied together by one common protocol. We've used a public standard protocol called Z39.50. This comes from NISO, the National Information Standards Organization. And this standard protocol lets all of the WAIS interfaces talk to any of the WAIS databases without the user having to know anything about that connection. And that gets away from having to learn different commands to log into different servers of information. The WAIS information can be stored in lots of different databases, from very simple ones running on a PC or a Unix workstation to a very large database containing millions of pages of text running on a connection machine. The connection machine is Thinking Machine's massively parallel supercomputer system. And it can run with gigabytes of information, that is millions of pages, and allows you to search the full text of every article in the whole database. That power to search that much text in under half a second lets you use a brand new search technique called relevance feedback. Relevance feedback means when you found a document or a section of a document that's relevant to what you're looking for, you can feed it back to the computer and tell it, this is what I want. Find me more like this one. And the computer will take that full document and compare it with all the data it has in every other document to find similar matches. It's really easy for the user. It's very similar to how you interact with a reference librarian today. You would go in and ask your question, the librarian would do a search for you and come back with a list of abstracts or headlines, and you'd browse through them until you found some interesting ones and say, that's what I want. Find me more like this one. The WAIS system is an experiment. It's running now with free software that's made available on the Internet from Thinking Machines, and it's being used to serve various kinds of data which people make available. Our goal is to make the protocol into something that really serves all of these needs and becomes a standard that more and more vendors will begin to support, so that there will become better and better interfaces to get at that data. Anyone who's on the Internet can have access to the WAIS system by getting a copy of it, and they can look at any of those databases which are on the network. So let me show you how it works. Here's WAIS Station running on a Macintosh, one of many platforms that you can run WAIS on. WAIS Station, when you first open it, presents two windows. The questions are the questions that you're posing to the WAIS system, things that you want to know about. And the sources are the places where you're looking for the answers. Sources are databases of information. And this window keeps track of all the sources that you've found on the network. We have a corporate email. You might have a whole organization's email, as we do here at Thinking Machines. There's a description of connection machine applications. We have Columbia Law Library Catalog. And then the directory of servers, which is an important source that I'll talk about in more detail later. And there's a long list of these sources out there which you can search, including government publications and cookbooks and so forth. The questions window keeps track of frequently asked questions or questions that you asked before and you got good answers to and you wanted to save those. You can use that to go back and look them up, or you could even pass them on to another user who could then retrieve those same documents. So we'll use the encyclopedia question, which I save as a blank question for frequently contacted databases like the encyclopedia. Let's look up Watergate as an interesting topic that is probably in the encyclopedia. I type a question, it could be many words, and I run it. The WAIS station contacts the connection machine using the C3950 protocol and gets back a response with the same protocol. The response is a series of headlines describing or titles describing the documents in that database. And we see that the Watergate article is the first one. When I double click it, WAIS station goes to the server and retrieves the text of that article. And we can scroll around in it and so forth. Now, that article is clearly relevant to the topic Watergate. So we will drag that headline, the icon, into the similar to section of the question here. Now, when we run this question, the connection machine is taking every word of the entire Watergate article and comparing it with every word in the millions of stories or millions of pages of text it has stored in its memory. The results are then scored or ranked according to how well they matched the original question. And the Watergate article, of course, matched itself very well. This article about Nixon matched about half as well, which makes sense. It has a lot of content in common with the Watergate article. This third article is a surprise. It's about journalism. So let's open it up and see why the journalism article came back. We find out, if you look at the scroll bar, that we've jumped right into the middle of a long document. That's because the connection machine can tell where in the article the match was the best. And if we read the text, we see that journalists have continued to serve as watchdogs and so forth, and it has to do with the Watergate scandal. And that article has a lot of text in common with the original question. Now, WAIS station has another interesting feature, which is that I can open up a new question, which I will move down here to a convenient position, and I can take my original question that I'm working on, and if I see something interesting that's sort of off the track on a tangent that I want to know about, I could say, oh, let's look up the Republican Party in general. I do that by dragging this article to my new question and then running the search here. This question will search this topic, and I'll see what's in the database that matches it and get a new set of results. And I could pick one of those to improve or refine or chase down my topic. I could also drag new servers in from the servers window and run this search across multiple servers of data. This is very nice because that question on that tangent could be pursued without losing track of my original topic, which was Watergate. Now, let's look at one more saved question here, which is the pictures. We have another feature of WAIS station, which is that it can display graphics as well as text. And if we look at this saved question, it was run with the query map, and it returned a series of maps that it has. If we open up the Kenya map, we'll find out that it can display graphics. Now, the final question that I'm going to explore here is the directory of servers, which is here. The directory of servers is how you look up where is another source or server of information. Suppose I want to know about poetry. I would type that as a question to the directory of servers, and this is actually running on a computer in California. It queries that and finds out that, yes, indeed, there is a source or server that serves poetry. When I open this document, I'm not going to get back text or graphics. Instead, I'm going to get back a source description, which is a description of how to contact this poetry server. It contains all the data that you need to contact over the network and the names of the databases, everything that the WAIS station needs to make that connection for you. The user doesn't have to know anything. There's a description that describes what's in that. And at the bottom here is a very interesting feature of WAIS station. You can tell it to automatically contact a source daily or weekly at a particular time of day. And this will be useful for sources like news that are updated regularly. This would allow you to have a series of questions automatically keep up to date on any new information that arrived on that topic in a particular server. If once I've saved that source, it actually appears in the list of sources as a source on the network that I can contact. There's our poetry source. So I've shown you how you keep track of a list of sources on the network. I've shown you how to use the directory of servers to find new sources of information on different topics. And I've shown you how WAIS Station keeps track of a series of questions that you might have run. And that's WAIS running on the Macintosh. In conjunction with Apple Computer, Dow Jones, and Pete Marwick, we did an experiment where we installed WAIS Station on the desks of 12 partners at Pete Marwick, which is a large accounting firm. These partners had access to their own data on their workstations, to their work groups data from their office, to the corporate-wide data, including all their standards and manuals and reports, and to the public news that was published by Dow Jones News Retrieval. They found this system extremely valuable in being able to combine these different sources of information to stay really current in their business. The current experiment that's going on is the internet, where thousands of users worldwide are playing with WAIS. And in the future, we look forward to an experiment in medical data retrieval with the Baylor College of Medicine, and with an experiment with the Columbia Law Library, where we will be scanning documents, in many cases old documents that can no longer be handled or circulated, and putting the OCR text of those documents into the WAIS system. This gives you full access to the text of those documents, in many cases where there was none at all, and it's a way that libraries will eventually be able to put their whole collections online. The Z3950 standard, which is the foundation of WAIS, the protocol between the servers and the interfaces, will be extended to handle all kinds of data in the future, not just text and graphics, but eventually sound and video and who knows what other kinds of documents. And WAIS is the first kind of system that allows the regular user sitting at a workstation access to supercomputer power that allows them to search vast libraries of information. Thank you.